to go through a couple more problems today, and that is absolutely my plan for tomorrow as well. None of these problems are necessarily more difficult than each other, but each one has different types of information in it. So some of you, like say, if some of you aren't very good at geometry, you might find the ones with the geometric portions to it to feel more difficult. Or if some of you aren't very good at trig, you might find the ones with angles to feel more difficult. Because there's definitely questions in the homework where you have something where the angle is changing size, and that would be a related rate problem as well. So I wanted to cover different types of problems each day, basically. Today is kind of all about triangles. It says top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute, which we should all agree that that's not a good thing. However, 3 feet per minute is real slow. So I'm not sure what's going on. Maybe the grass is giving away, I don't know. When the top of the ladder is 7 feet from the ground, and we all know this is an impossible actual problem. What is the rate of change of the distance between the bottom of the ladder and the wall? So we would kind of expect, bless you. Like when I say this is impossible, there's no way that it's going down the wall at 3 feet per minute the entire way. Because you would think that as you got closer, your weight would cause that to pretty much just completely give way and flop down. But that doesn't matter. We're just going to kind of go through this and figure out the parts. Maybe I should start us off by drawing the picture at least. I don't know if you guys can't picture it or not. Oh, actually, I forgot. We got a triangle button. I have not changed the shape. Okay. Good enough. Okay, so this is the house, you know. And this is the grass. How many pencils are you sharpening? You like retrieving use more than one per hour?
Yes.
Really?
Yeah. Not much of a class, but I can never hurt to have 3 pencils.
Why don't you switch to mechanical?
I ran out of lead in my mechanical pencil.
Okay. I was going to say, that seems like the perfect situation for a refillable pencil. Okay, are we all right with how this is set up? Could you guys visualize that ahead of time anyway?
Yes.
No. Oh, okay. Well, it's a good thing I drew. Well, we should write down any kind of information we know. And or maybe I should come up with labels ahead of time. I need to call this distance something, I need to call this distance something. Should we just be super generic and go with X, Y? Okay. So that distance, that distance. Says the top of a 25-foot ladder. Well, if we're told that this is 25 feet, then that's telling us the ladder will never change size. It's a constant distance. You know, some ladders can change size, but this one, we're told, is just 25 feet and that's it. So as this is sliding down the house, it's still going to be 25 feet. Okay, sliding down a vertical wall at a constant rate of 3 feet per minute. How would I write the rate for going down the wall? Okay, dy dt would be the label, because that's how fast that height is changing. And then what would I write as the answer? -3. because it's going down. I don't know if I can fit feet per minute. We'll go with it, okay? When the top of the ladder is 7 feet from the ground, so this will be at a certain moment, what is the rate of change of the distance between the bottom of the ladder and the wall? So it's wanting to know how fast is this distance changing. So dx dt is how fast this is changing. And that's what we're trying to figure out. Okay, so that's all the information we know. Oh, go ahead.
Would y there equal 7 or you plug in 7?
I will be plugging in 7.
Okay.
Because this will change depending on the situation. The one moment we want to look at is when it is 7. So you can kind of think of it either way, but y isn't constant, so I'm not going to write 7 instead of 1. This one I can put 25 because it's never going to change. Okay, I guess the big question here, we've got derivative stuff, we've got numbers. What equation are we going to work with? Yeah, the Pythagorean theorem is kind of the only equation you know that talks about how long each side of a triangle is. So since that equation deals with that information, that should work for us. If for some reason in the problem it was mentioning about the change in area, then obviously you do area of a triangle. It all depends on what we're focused on. So I'm going to go with a squared, nope, not a. How come not a? We called it x and y, yeah. So we've got x squared plus y squared equals 25 squared. Yeah. If something is variable and can change, you put a variable in place of it. If something is constant and never will change, you can put a number in place of it. Okay, so then I'm going to take the derivative, which would be 2x dx dt plus 2y dy dt 0. If for some reason you didn't put 25 in place of the ladder, we could, like if you wrote a variable here, and then you wrote, I don't know, L, right? So if you decided to write 2LD LDT, dl dt would be 0 because the distance of the ladder isn't changing. So even if you forgot to put a number in here, 0 would go in place of the change in the ladder. So it would still turn to 0. Okay, we should call him something. What are you doing? Yeah, you had him yesterday too. Can you help me start off? What should I do? I mean, I definitely could, but.
Do you plug in the 7 for y?
Sure. So you're just basically plugging in a number you know?
Yeah.
Okay, done. Unfortunately, there's a lot of other things missing. We've got 4 different variables to fill in. One of the variables we're trying to find, so dx dt should stay in front.
And then dy dt will be
Perfect. What about x?
I bet you could talk about that since we have to
Good.
do the hypotenuse.
Yeah. Sometimes you're going to have to find some of these numbers, but you would always be given information to be able to do that. So if we were talking about the moment in time when this was 7, we know this is 25, so we could actually use the Pythagorean theorem to figure out x. I think that's 24?
24, yeah.
Yeah. Traditionally, they're going to give you the numbers for Pythagorean triples so that your problem doesn't work out terrible. So like 5, 12, 13 is going to be a common one. No. Yeah, 5, 12, 13 I believe it is. 3, 4, 5, 7, 24, 25. There's one more, I can't remember that. Go ahead, what'd you say? So, the X, we weren't told it. We were gonna have to figure it out, because we were told the number on the side, and we know the number of the ladder, so we would use the Pythagorean theorem to figure out X. And I just knew the answer because it was a Pythagorean triple. Like 3, 4, 5 is the common one, 7, 24, 25 is one. Okay, and then I just kind of calculated. So what do I got? Negative 42, brought to that side would be 42. So dx dt, 42 48, is that 7/8? 7/8 feet per minute. Because it's a positive number, that's saying that it is getting bigger and going out. If dx dt was a negative number, that means the ladder would be coming closer to the wall. I don't know, go ahead and ask. Like, this one traditionally feels more complicated to students than the first two. I mean, it is set up the same. The main difference is that you have to find one of the numbers on your own. Okay? Do you guys need a minute to figure out if you need to ask a question? Because otherwise, I was almost thinking, do you want to try the bottom one on your own? Okay, because I believe the bottom one is also a triangle, if I remember right. Oh, I remember this one. What on earth is over there? Is it all sprayed everywhere?
No.
Okay.
It doesn't mean to start out exactly like.
It does mean it starts, at
He's
noon.
like 12 a.m.
Actually didn't see that.
Hey, this is, at noon, this is what was recorded,
Alright.
and then they were changed.
Always read the question.
That is true, always read the question. If you are having trouble picturing it, that's kind of what it's saying. Oh, let me go to you. You've got two ships that were apart. They're moving different directions. 4 hours later, it wants to know how fast is the distance between the ships changing. So this is still Pythagorean theorem. It's just a very different application of it. But you guys are supposed to try to find the same type of information as the latter one. Is the part that's confusing to you the noon and the 4 p.m. part? Okay. You can label them whatever you would like. I'm just gonna go with pretty generic ones. Oh, my picture's way up.
Yeah.
That's square root of 10,100.
Yeah. Or 10 square root.
Wait, what'd you say?
Or 10 times the square root of 100. Or 10 times the square root of 101.
Oh. So it does work out perfectly. I didn't think it would, but okay. Honestly, simplifying here won't necessarily help us because we're gonna most likely have to use a calculator. And if you want to simplify, go for it. The only reason it tells us the noon portion is to tell us how far apart they are originally. And then when it gives us their speeds, it's telling us how far it moved in 4 hours. So after 4 hours, this would be their current positions. So this is going to become X, Y, and C. And we were already given dx dt and dy dt. And dc dt is what we were trying to calculate and figure out. I don't know if I have enough room here. I'm going to go kind of move down. 2 times 10 times negative 35 plus 2 times 100 times 25 positive 2 times square root of 101. This is 100% going to be a calculator one. These are obviously too big to do in your head nicely. I mean, I guess this isn't horrible. 500 minus 700? Negative 200? No, that's not right. This is 5,000. 5,000 minus 700. 4,300. So 2 root 10,100 divided by 4,300. Is that right? Did somebody already calculate the final answer? 21.39. Somebody else get that? Should I calculate this too? Let me grab my calculator. Are you guys okay with where I got the numbers from, though? Should I start there? Okay. 2 root 10,100 divided by times 10.
Yeah, I got that as well, that's what you want.
You got 31 hours.
After 4 hours, you know how to park in trouble.
Little questions?
Yeah, 21.39.
No, what, it had like this number, like.
That would be what, kilometers per hour?
So console. I forgot to do that.
Boy.
Okay, oh, go ahead.
Why would the 35 be negative?
So if you think of the x-axis, moving to the right would be positive, moving to the left would be negative, because the negative just means the numbers are getting smaller. It was 150, after 1 hour, it would be 115, after another hour, it would be 35 less. So the positive and negative just means if your answers get bigger or smaller.
So like if the 25 was going down, then it would be negative?
Correct.
Okay.
Like on the previous problem, the ladder was going downwards, so the wall length was shrinking. Okay, I wanted to give you about 15 minutes so you guys could try a couple of problems in the homework. Tomorrow I want to try to find a angle one.
What is this 21.39?
Kilometers per hour is approximately the answer.
Okay.
I knew I wouldn't have room to fit all the labeling with the numbers, so I kind of had to